Okay, let's look at a new set of old AP problems that fall under the category of differential equations, which I find highly likely for this year's exam given the format. So this one's a little interesting. It's from 2010, and it gives you the equation that the derivative is xy cubed, the second derivative is y cubed times 1 plus x squared y squared, and that f of 1 is 2. Part A, pretty straightforward. They want you to find the equation of the tangent line at x equals 1. So they're basically giving you a point. So that's 1 comma 2. So you can almost already tell that your equation for your tangent line is going to be y minus 2 equals something times x minus 1. Now we just need to get the slope, and to get the slope we use the derivative, and for us this is a really short process for this problem because they've already taken the derivative for you. So you just need to take the point 1 comma 2 and plug it in to get the slope, and then we should be okay. So this is 1 times 8, so this is just 8. So take that 8, throw it in here, we should be good to go. There's part A. We've got a tangent line. Part B is looking for a little bit more. Part B says to take your tangent line that we just found, estimate 1.1, and then figure out if that's basically an overestimate or an underestimate. It says, is the approximation for f of 1.1 greater than the actual or less than the actual value of f of 1.1? So we're basically asking you to whether that's an overestimate or an underestimate. So let's get to it, but I think I just need a little bit of room. So for part B, we sort of need this tangent line still. It might actually be easier to look at your tangent line like this for purposes of this problem. So for our approximation, we're going to say f of 1.1 is what you get when you plug 1.1 into the tangent line. So this is 8 times 1.1 minus 1 plus 2. This is 8 times 0.1 plus 2. This should be 2.8. So graphically speaking, what we're saying is the function at 1 makes 1, 2. Your tangent line has a slope of 8. And then we just want to know whether this is an overestimate or an underestimate. So we say if you go over 0.1, the tangent line goes up 0.8. And the line and the tangent line and the curve should be relatively close together as long as we don't stray too far. So the kind of question becomes, does the curve kind of look like this, and then at 1.1 we're underestimating it, or does the curve kind of look like this, where we're overestimating the value? So it all just kind of depends. So ultimately, we need to figure out, basically, the key in this thing is the concavity of the curve. So that for us is going to be the second derivative. So for the second derivative, we should just take our value. And just see what we get. Or sorry, I don't know why I'm plugging in the value. So for the second derivative, you could plug in this and see whether you're concave up or concave down here. But ultimately what you care about is what's happening between 1 and 1.1. And between 1 and 1.1, we're talking y cubed times 1 plus x squared times y squared. This second factor is actually easier because this guy's positive because you're squaring them. You're going to add 1. So overall, this whole second factor is positive. The other thing we kind of know is that y cubed, we already know at 1, the value was 2. We also know we're increasing because this derivative is 8. So we got something that's positive, so this function is increasing. So if we cube any number, any y coordinate, even though we're not entirely sure what they are, we're sure that the function is increasing. So every value is at least 2, and it's growing. So ultimately, this is positive. So your second derivative is positive, which means we are concave up. Which means we look sort of something like this curve, not like that other curve. So if we're concave up and increasing, this should be a dead giveaway that 1.1 on the tangent line is like here, but 1.1 on the actual function is higher. So the tangent line, the approximation is less than f of 1.1 because the second derivative is positive. You could say something like we're concave up instead. Should be fine, but the concavity sort of dictates the answer here. The third part is to just solve this differential equation. And I guess we could actually confirm this in a slightly different way now. Part B, you could do part C first and then use your answer from part C to do part B. But this one just asks you to solve this differential equation. So I would multiply both sides by dx, and then I'd divide both sides by y cubed. And then you should get to the point that you have dy divided by y cubed equals x times dx. Might be easier for you to do this problem as 1 over, or sorry, to think of this as y to the negative third dy equals x dx. And then it's maybe been a little while since you've done some of these, but just take the antiderivative of both sides. Antiderivative of y to the negative third should be y to the negative second. Bump that value up by 1, divide by new value, slash throw a negative 1/2 in front. This should be 1/2 x squared. Don't forget your plus c, and then we're sort of okay. Then you kind of have two options. When they say to find the particular solution, they're basically telling you have to find the c and also isolate the y. When they say y equals f of x, we need to get y all by itself, and we also need to figure out the plus c. I am of the opinion that we isolate y first and then find the c. I usually find that easier. So I would start by multiplying both sides by -2. And then you wind up getting y to the negative second equals, multiply this, you should get negative x squared, and you can still just keep calling this plus c. And then I'd get rid of the negative second power by raising both sides to the negative 1/2 power. And then you should get y is equal to negative x squared plus c all to the negative 1/2 power. If you want to rewrite that with a square root and flip it, that's fine. I don't know if we necessarily need to do that. But now we should be able to plug in the c. Weird, small, super important issue though. We need a plus or minus here. Because when you raise both sides to the 1/2 power, you're basically taking the square root. We're raising both sides to the negative 1/2 power, so we're taking the square root and we're flipping it. But if you ever do something to both sides where the fractional power has an even denominator, that's just like you're taking a root. So you need a plus or minus here. And we'll sort out these issues in a second as far as whether it's a plus or whether it's a minus. Remember, it's telling you that the thing is a function when it says y equals f of x. That's the fancy calculus way of saying, hey, this thing is a function. So no plus or minus should be in your final answer, and you should be able to figure out what's what. So based on our thing, which is f of 1 equals 2, we know that 2 has to equal plus or minus negative 1 squared plus c to the negative 1/2. And then we're basically just good to go. If our final answer is going to be 2, dead giveaway that it's the positive. So we've already kind of figured that out. Now our only thing left to do is find c. So 2 equals 1 squared is 1, but now it's negative 1. This is negative 1 plus c to the negative 1/2. So I would just raise both sides to the negative second power. Multiply those powers. 2 to the negative second is a quarter. These should cancel, and you get negative 1 plus c. Add the 1. 1 is really 4 quarters, so you should get c as 5 quarters. So officially, y is equal to positive. You don't need to write the plus at the end. Negative x squared plus 5 quarters to the negative 1/2. If you want to rewrite it with roots instead of fractional exponents, that's fine. If you want to flip it because it's negative, that's fine too. But I think it's just less work to leave it like that. That's it for the differential equation problem.